Hello again. Here's notes for day 2. All right. We started talking about polynomial functions, noticing that how you tell what the degree of a function is, and what that degree tells you about the end behavior of the graph of that function. We also talked about the 2 different ways commonly used for writing polynomial functions: standard form with the descending order of exponents, and then factored form, hugely important because it tells you the x-intercepts. Okay. Whoa. There we go. Next page is seeing how you can use those factors to find the x-intercepts. Okay, a few examples of that. Also noticing that the x-intercepts are called zeros or roots, and that the number of factors always equals the degree. That statement will be tested as we go through this chapter, but we'll find that that is always true. A few examples on how to sketch some polynomial curves using the end behavior shown by the degree and the zeros, okay, and how to do that. A couple of examples of that. Here's another one where we saw a multiple root, a root with a multiplicity of 2. That is, the factor is squared, okay? And that gives us kind of this bounce-off point of the graph instead of a crossing point where the other 2. So x plus 1 gives us a root at -1. It crosses at +3, but it doesn't cross at +1. It bounces off because that factor is squared. There's your problem set. I got the video problems choices on the Neo page. Here's a couple of examples, that we did out of that problem set to check your work. Number 13, number 15, number 21. And we talked about polynomial division. Okay, and we did a long division example, and it's a lengthy process. I'm not going to go through it on this little short video here. Hopefully it made sense, and if you need to look at it again, you can see it. You can certainly look up on YouTube polynomial division and find plenty of videos showing you how to do that if you're rusty on it. Synthetic division was our next topic, and it only works in some cases, okay, and it's very useful process. We didn't really get into the points of why we would do this. We'll talk about that tomorrow. But we did one example of synthetic division, and a couple of points about that example. We got a remainder of 7. That's notable. We also saw that these numbers down here are result. That is the quotient. That is the coefficients of the quotient. Okay, so pay attention to that. And we also pointed out that you can use the synthetic division process to evaluate a function, that is to replace the x value with some number to figure out what it equals. Okay? And one example from the class set on, I think that was number 5. Okay, bye.